Hello and welcome to this episode of Tech Please. This is Chen Chen from Beijing, and today we're joining the search for Earth 2.0. So, Earth 2.0. You all heard about that term? Well, let's talk about finding planets first. To look for planets, NASA used to have the Kepler Space Telescope, and Europe had ESA Gaia, well, at least until 2025, which is its life expectancy. And remember the newly released deep field images of our universe captured by NASA's Webb telescope? Not only did they amaze us all, but we also learned that Webb will be used for collecting data about exoplanets, or extrasolar planets. In fact, even before Webb, over 5,000 exoplanets had been discovered and confirmed by scientists, with around 50 Earth-like planets in the habitable zones. Now, don't get excited too soon, because most of them are hundreds of light years away from Earth, meaning it could take us millions of years to travel there with our current fastest spacecraft. Now, with so many possibilities and unknowns out there, China launched its own plan to look for nearby habitable planets in May. The project, called Closeby Habitable Exoplanet Survey, or CHES, if carried out, will be the first space mission specifically designed to hunt for habitable Earth-like planets around nearby sun-like stars via a space telescope. So, how is CHES better for exoplanet discovery? Well, to observe a planet is fairly easy. Scientists identify planets on a daily basis using a combination of the transit method, the radial velocity method, direct imaging, or gravitational microlensing. Now, I know that's a lot of terms that I will not expand in this episode, but you can Google them if you like. To determine if a planet is habitable, meaning suitable for life to evolve, there are a few vital things that scientists are looking for. Firstly, if it orbits in a habitable zone of its host star, or what the scientists call the Goldilocks zone, or a distance that's not too close or too far to have liquid water. Water is always important, right? And then, of course, you want to know the size of the planet. Scientists always want it to be a lot larger than our planet Earth, because they believe that the larger the planet is, the higher chance of it to have a gravity that can hold on for atmosphere. And then the star must be a certain type, preferably a red or yellow dwarf star, just like our sun, that has had a stable existence for over 4.5 billion years. And all of that cannot be done by just looking at it from Earth, right? So CHES will observe around 100 sun-like stars that are specifically 32 light years away, and will hopefully discover roughly 50 Earth-like planets, or they should be called super-Earth planets that are up to 10 times the mass of Earth in habitable zones. The project will feature a 1.2-meter aperture optical telescope that's able to take high-quality images, and it'll be placed into a halo orbit at the second Lagrangian point of the Earth-Sun system, and maintain a stable operation for a period of at least 5 years. And CHES will conduct extensive survey on the number, true planetary masses, and three-dimensional orbits of those habitable planets. Now, that's a lot richer than those predecessor telescopes provided. But maybe with all these powerful telescopes, whether for the one from China's CHES mission, or Webb, or Gaia, we'll soon find out a Tatooine lying somewhere in the universe. As for the question of how to get to an exoplanet is for another episode of Tech Please. This is Chen Chen. Till next time.